Hello, guys, it's Manuel here again, and I am coming to you with a project that I've been working on for a while. So, this is a tic tac toe game, and I used CNN, which is Convolutional Neural Networks, to create it. So, basically, I was just playing around with Pygame, and mostly what I've been seeing online is using um, it's just basically using clicks to play the game. That's if you click on, let's say, a box, for example, you can play as X or O. But I decided to just do something more interactive where I could draw the shapes and, use that to be playing. So, okay, let me just show you a quick demo. Just 1 second. Okay, I think that's okay. There's the code. So I play this. Where are we? Okay, so we have X and O. So I choose X, and normally if I click this for most games or most tutorials that you see online, you tend to see like the X shape come up, and then the AI plays the O, and then you play your X, and like that. But for what I decided to do, I just decided to do something like this. I can click on this box, I can draw my X, can play, and we have an O there. Let's see X. So we have an O. Okay. Let's see if I can beat this. I doubt I can because the algorithm is quite unbeatable, or it's meant to be unbeatable. So um, there's really no way for me to win this. So the only way I could actually confirm a few things was to actually lose intentionally and check it out. Okay. So if I do this, for example, I say X. So we have O. Okay. Let's see if I can lose intentionally here. Pressure to block me. Okay. Normally I'll play here. And for this, I'm just going to play here. I think that'll be far better. So, see, that wins. Fortunately, I had to let it win. So, this is quite unbeatable. So, I'm just going to show you guys how I implemented it. I might just show some math and just give an overview of how I implemented this. So let's see how it goes and let's get right into it. All right, so okay, let's get rid of this one. So just gonna minimize this. All right, so how do we start with this? Okay, just gonna make sure I'm on the screen. Okay, let me see if my stuff is. Oh, I think I was holding my drawing pen wrong. Okay, now that seems right. So let's say hola. So that's I think that's Spanish for hello. Oh, I hope I'm right. All right. So the way this works is basically we want to have our tic tac toe game like this. Okay, maybe this might not look very nice. Okay, we have something good. We have something like this. So usually when you just click, like I said before, usually if you click a box, the shape comes out, and you and the AI or you and the algorithm play back and forth, and you have your game. Although this one we're able to draw our shapes like I just showed you earlier. So the main thing or the main thing that we're implementing here is the CNN, and I'm just gonna quickly brush on that. It's not quite hard. I mean, it is something that is very popular, so I'm very sure a lot of you might know about it. Well, I'm just going to rush through it to to rush through it really, just to rush through it. So all right, basically for those of us that might not know what it is, or for those of you that might not know what CNN is, that's convolutional neural networks, and it's basically a type of neural networks that use a type of neural network that use for image classification. And for this one, we're going to be classifying X and O in this case. So this is what we're going to be classifying. And basically how it works is this. So let's say we have a picture right here. All right, please do not laugh in the comments about my drawing. Let's just hope this goes well. All right, so let's say we have a smiley face in this picture. Okay, we have a smiley face. Okay, that's some teeth. Yeah, all right. I believe everyone is beautiful in their own right, and I believe my drawing is also beautiful. All right, so let's say we have something like this, for example. Okay, what will I use? Okay, let's say we have this kind of grid. So we have this kind of grid. So basically, if it was a person that was looking at this picture, you could immediately tell that, you can immediately tell that this is a person that's smiling. And the reason why it's easy for you to say that is because there are some shapes that you're able to, recognize. And once those features or once those shapes come together, you're able to say, okay, this is a face. Is it ugly? Is it beautiful? I don't know. But you know it's a face. You know it's a human face. Now, computers cannot really do that. But what we tell the computer to do is we tell the computer to divide the, or we tell our program to divide the picture or whatever it's looking at into different boxes. So we have something like this, and then you could have a range from 0 to 255. For, let's say, 0 could be the highest for the brightest, and 255 could be the most activated. So what I'm trying to say is this. So you can see that there's no drawing inside this particular box, for example. So you can say this is 0. There's no drawing inside. The face is in there. You can say this is 0. You can say this is 0, 0, 0. You can say this one's 0. Nothing's there too. Now there is a little bit of something in this. So we can say, let's say, can just say, just for example, say, let's just say this is 100, for example. Now there's a bit more in here. We can say this one is 150, and we know that for this box here, we can see that everything here is lit up, or everything here is going to be it's going to be more of a dark figure. So we have something like, let's say, 255, because the whole thing is covered up. So basically that's how pictures are done. And what you now have right here is an array of numbers that we are going to process. And these array of numbers are quite similar to other arrays of numbers that could have, similar features. And then that's how we're able to use CNN to classify things. Because if this looks like a face, and let's say do something like this, let me try and see if I could do something ugly. This also looks like a face in a way, but it's not the same thing, but then it does have some similar features. Once we've trained the CNN model with this, then we can also use that same model to say, okay, it looked at it and it said, okay, well, these parts were not activated, these parts were activated, something like this was activated. It had like a circular figure, and this one has similar to a circular figure. And then it says that, okay, this is a face, and this one is also a face. All right. So you can say something like that. This might not really be the best representation. Ideally, it should be. I'm not sure how to use the colors in this thing. That might take some time to draw, but basically just know that we have 0 as the brightest. There's literally no information on it, and then we have 255 to be like the darkest. So that's basically the whole thing when it comes to like representing pictures as arrays or numbers, quite to put simply. All right. So next up, once we have our arrays of numbers, we usually the next thing that we usually look out for is, okay, this is our input. All right. So the next thing that we usually have is a filter, or a kernel, or a convolution is it's basically a convolutional layer. And what I'm trying to say is this. Let's say we have this array right here. I said we have this array of a picture right here. Just trying anything. Okay, I said we have this and we have some numbers. Okay, so we have a few numbers. What we're going to do is we're going to have a filter, and what this filter is meant to do is to extract some information. Now, these filters are usually 3 by 3. Most of the time they're 3 by 3, and they could start off to be random. Let's say 111, 0, 1, 0, 0, 0, 0 something. All right, and what you have is this is going to be sliding over this. This is going to be sliding over this. For those of you that are familiar with the topic, you'll probably understand what I'm saying. But just to give a high level overview, you put this numbers over this, and you get a particular result. And at the end of the day, you could come up with something like this. You come up with something like this. You come up with something a bit smaller. Say a bit smaller. Let's say you have some few numbers that are here. All right, you have some few numbers that are there. And okay, I forgot to mention these numbers will be chosen at random. They are chosen at random at first, but we tend to use back propagation to. Oh, this is taking a long time to write. All right, we tend to use back propagation to make it more meaningful. So you could start off with something like this, but then at the end of the day, you could end up with something like this as your filter. Oh, that's way too slanty. So let's say 1, 1, 1. Then it has more like a pattern. So 0, 0, 0, 0. Okay, yes, one. All right. So we have more of a pattern here that makes more sense rather than this. This doesn't look too nice. Well, yeah, we basically use backpropagation to get things to be more meaningful, and then at the end of the day, you have features that are actually making more sense. So let's say, okay, I think I'm just gonna draw it out for it to make more sense. All right. So we could have something like this now. So after sliding our convolutional layer over the picture, after sliding the filter over our picture, we can now have something like this. We have a reduced picture. Now like I said, some of the features will have been taken away. So next stop okay, oh, I forgot to mention earlier. This is used with an activation function. It's usually ReLU in most instances. Something like this. Okay, that doesn't look right. Okay, forget this. So we use something like this as our activation function. Something like this as activation function. So this is a ReLU. This is mostly used. So this is combined with this to produce, something that has been filtered. But I think I'll just put some links to show you some channels that have gone into the in-depth analysis of how these things work. Okay, so just continuing, the next part is we have our pooling layer. So this part is called pooling, and basically what that does is also to extract some features. Now, let's say we have something like this. Okay, let's just say 101. I think it would be nice if I just make it. Should I? Okay, we'll just do something like this. Let's say a 4x4, for example. All right, so let's just put in random numbers. 0, 0, 0, 1, 1, 1, 0, 1, 0, 1. Okay, so what next? The next thing that we do in this kind of situation is we have a pooling layer, and our pooling layer could be something like this. So we have 1, 0, could have something like this. and this goes over this. And what you could have now is, okay, no, oh, sorry, I think I'm making a mistake here. So I'm still talking about CNN. Okay, so we have a polling layer. I don't think we use anything like this. You just have something that extracts, you just have a window that extracts something like this. And it doesn't really use an activation function, or it doesn't multiply anything like the convolutional layer. What it basically does is it could just take the aggregate of this, and this could be, or even the maximum, and then this could come out as, let's say this one could be 1, this one, okay, not using this, you could just say this one could look something like this at the end of the day, 1 0 1 0. This does not correlate to this, so please do not take this literally. Well, just to try and make an example here, so you have this, it's going to slide over this, and most of the time this could be a mean, or it could be like the maximum or something like that. That's basically what it does. Um, so now we have this, we can have something like this, and then another part goes like this. This goes here, and then we have another window that's on this side that comes here. All right. So we basically, this is our polling right here. So we have our polling, and next up, okay, now we can see that this has been reduced. Okay, so now we just take these numbers. This will be shown better in the code. This will be shown better in the code. So we could just have something like this on 1 0 0, and now we can just use our feed-forward network. Just do this, and now do this, and it just becomes like a normal neural network at this point, basically. So this helps us to determine if it's going to be, let's say, in this situation, now this determines if it's going to be an O or an X. So it's be an O or an X in this case. So that's just basically an overview of the whole thing, or just like a concept. But the numbers here are, don't take the numbers literally, please. All right. So we have O, we have X, and basically, okay, I think this one's going to be combined with an activation function we just use right here. And this, okay, I think we have our weights here. Our weights that helps us with that. And then we get the sum in this node, and then the node is combined with the activation function, and then we predict one of these. All right, so basically that's just an overview of how it works, and right onto the code. I think that's probably the more interesting parts. All right, let's get that on the way. Okay, so moving on to the code now. Okay, I think I should have named this a bit better. Sorry about that. Okay, so looking at the code now, first part that we need to do is install our dependencies. We have shuttle OS for doing the basic OS stuff, getting our files and everything. We have matplotlib, numpy, and okay, we'll be using TensorFlow for this. TensorFlow keras, zip file. This was because I downloaded the dataset from Kaggle. I downloaded the dataset from Kaggle, so that's why I had to use this to extract the data. Normally, I could have extracted it normally, but just felt like adding some lines to the code to look nicer. But yeah, that's the zip file. We have the zip file there. Then we have matplotlib again, and also TensorFlow. Just some things in TensorFlow that we'll need to use. We'll see that down the line. All right, so if you're wondering what this line is, I think I just copied this from somewhere. This is to suppress info, warning, and error messages like it says here. basically it's quite annoying when you see some of those messages popping up, and they tend to make the whole thing just look ugly. Well, yes. So what I did was I downloaded this zip file from Kaggle, and this contains a dataset of letters and numbers, basically just hand digits. So we could have something like this. I think you could have A, B, C, D, and you can have. So what I really needed from that dataset was X and O, and then also the O ones, the ones that were drawn. I will see that later. Well, moving on. So this part is to extract our. This part is to extract the zip file. Okay, I think I'm just gonna show it out. Just give me 1 second. Okay, so here's my file. Okay, I'm going to delete these. That's not for now. Okay, I haven't deleted something important. All right, so here's our archive file, and I'm just gonna open it. Okay, we can see we have English, we have images, so we have the images right here. Just going to expand this. Just going to expand this. Okay, I don't think I'll be able to view it in this. Okay, because I think it's because it's still in the zip folder. That's why I can't show up. All right, okay, that's disappointing. Anyways, we'll be looking at this now. So this helps us to pin this out. Okay, I've already run the code, so we're just gonna see it right here. So we can see all of our code right here. And if I run this again, okay, let me see if it hasn't been run already. Okay, now just look at this. If I run this again, okay, I think it's just extracting everything. Just give it a second. All right, so I think ideally everything should be out here now. Okay, yeah, here we go. So, so here are our images. We have all the letters and numbers and everything. I think you can see that right here. We have the different ones. So I got this one from Kaggle. I'm gonna post this. To be honest, I can't remember exactly. I can't remember the exact link that I got this one from, or the exact place I got it from on Kaggle. But I am going to post it on my GitHub. I'll put a link below so that if you want to follow, you can just get the same one. Well, basically, this is the same. This is what's showing us the letters and the numbers. So here are our O's. So thankfully, we have more O's because 0 and the letter O do look alike. So we have more on our plates, which is very good. All right, so that has been sorted. So now what we're gonna do is we're gonna use pandas to read our English data sets. And okay, all right, so basically the information for the data set was in this one. I think it was right here. Let me just see if it's still there. Okay, English, yeah. Okay, should I open this? Let's just see if it's able to give us something nice. Alright, so it does look like, it does look something like this, and this is in a CSV format. That's why it looks a bit weird. So we have each of the images, and the labels are right there. So all we're just, I'm just gonna say don't save. All right. All we have here now is our images and the labels. So what we need to do is extract the ones that are 0, O, and the ones that are also X. And we're going to also extract, okay, no, sorry. I think I was just going to extract the images, but we're going to use the labels to extract them. So that's what we did. Sorry, I almost forgot what I did there. All right. So you can see once I put this is the head. Okay, like the first 5 ones. Okay, if I do, let me see if I do so. Let me see if this will work. Okay, yeah. So you can see that's the end. We have tail. Those are the Z's. Those are the last ones. Let's change this back to head. Seems a bit nicer. All right, so we have head, and these are our first 5. And the next thing we have is using our labels, we're seeing the unique ones. So what we're going to be extracting is this that will serve as, that 0 can serve as O for us. Then we have big letter O and we have small letter O. So that's why this is here. Then we also have small letter X and what's X again? Where's X? Okay, yeah, big letter X. There we go. All right, so those are things we're going to extract, and we're going to separate those into O data and X data. So now we're just going to use this one, and basically this is saying that using the label as a reference point, if the image label is in one of these, then we should extract our O values. Now we have our O data, we have our X data. So we have our O data here, you can see it right here. So if I do tail for this one, you can see this is just small letter O right here. All right, so if I do the same thing for our X data, okay, I'm just ahead. You can see that's going to be the ones that have X. So there we go. So that's X, 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 and the rest, yeah. All right. So this one is basically just using pandas to filter out the ones that we need. So the rest of these other letters, we don't really need them. Okay, so the next thing here that we need to do is actually to separate our training and testing data sets, because we need to train the model. As many of you might know, we need to train the model, and then we'll need to test it with some things that the model has not seen before. So basically how this works is, for each of these files, for each of these values that are here, I'm going to create a folder, and if they exist, then there's no need for us to create another one. But if they don't exist, I want it to be created. So basically that's what it is. So this os.getCWD, it's going to be different from you, because you're probably going to be using, if you're implementing this, you're probably going to be using your own personal, you're going to have your personal address here. So this is where mine is located. You can see this one, you can see users, EAD, and blah, 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 has been created successfully. So if I run this again, let me see, you see that ideally it should say already exists. Let's try it out. Okay, created successfully again. Okay, that means it wasn't there before. Okay, we can see that's there. All right. So it's there because it already exists. Okay. But now if I delete this, let's see if I delete this. What it's going to say now, it's going to create another one. Yes, so now it's been created successfully, and now we have our folders there. Okay, so basically that's all this is saying. If this does not exist, make this directory, that's os.make this, and we're going to say for subfolder in subfolders. Forgive the language there, because that sounds a bit confusing now that I think about it. But basically this is just a for loop that's just going to help us do that. Okay, so for subfolders and subfolders, make the directories. This one basically joins this directory right here, this folder that we created right here, with subfolders with this. All right, so for X need you to join this with this directory right here. So you have, okay, let's see if we got that right. Make this join directory support. Yeah. Okay, yeah. Basically, just creating that for us. Then, okay, it does look a bit confusing now. This is okay, true. Directory subfolders. Okay. Okay. All right. Okay. Yeah. Yes, that's still correct. So we have our directory right here, and for subfolder. Yeah. So basically, that's just saying that if, okay, like I said before, yeah, I think this is okay. If the folder exists, create one. If it doesn't exist, don't create one. So that's what that's doing right there. All right, so next up we have splitting the training and test images. And for this part, what's going to happen is while splitting the images into its training and test parts, how it's going to work is basically this one's a dictionary right here. We have our items. So we have our train source, we have our test source, and now remember we did our subfolders right here. This is X and O. Like I said, this one's make this directory. So we have directory. This is a directory right here. And if I go into here, we can see that we have our O and our X. Okay, this was the test folder. Okay, you can see our train folder here. You can see OX, and right here we can see the same thing for that. So we're going to use that to help us to, split the training and test images. So like I said, we have our train source, we have our test source right here. Then our images is just going to be this directory. All right. And our training size, this is going to be 80%. Let me just put a comment on that so it looks more appealing. All right, so 80% training and 80% training, and then we use 20% for, we'll just use 20% for our tests, our first test sets. All right. Ideally, we should have a validation set, but I decided not to go with it because I'm just going to use what I draw to do the evaluation. All right, I'm just going to use what I draw to do the evaluation and just see how it is. So basically, that's why I'm not using it. But ideally, it should be something that I should be using. But for this particular project, I decided not to go with it. All right, so for letter images and value image, we have our path to be this, and what this is trying to say, if the length of the train source key, okay, that's not one word, if the length of this path, if this length of all the images in our training folder is less than the training size, then we should copy it into our training folder. So that means, so basically, if our training folder has not been filled up, then we should, we should keep on putting images in there. But if it has been filled up, that means that's why this else is there. If it has been filled up, put all the images into the test folder. Okay, so I think this one should be empty now. Let me just check if I haven't done that. Okay, you can see that this is empty. Now, if I run this, just give it 1 second, and I go back, there we go, see? So now, let me just make this view nicer, large icons. All right, so you can see this is our O, and right here we have our X's. So this is basically This is basically okay. Let me see something. Let's see. Let me show something. Let's see if this works. So let's see how many x we have. Okay. So if I do this times 0.8, let's see what we have. So we should have 80. Ideally, we should have 88 images right here. Let's see details. Yeah, see, 88 items. So, and now we have our test folder right here. And x ideally should be what okay, this one should be 0.2. So there should be 22 here. There we go. See? So we have 22 right there. All right, so that's how I split my training and test images. And the next part that I did, what I did was, let me just come here. So for the fact that we're going to be drawing, or for the fact that our user or we are going to be drawing on this, let's say this is a particular canvas that we're meant to draw our shape. Now, ideally, most people might, just draw an X like this, draw it the normal way. But then there could be some instances where we have something like this, it's right here, or let's say someone just puts the X right here, or it's not even an X at all, maybe it doesn't look like an X. Let's say something like this, it's not really straight, or something like that. So it is very important for us to augment the images since we're going to be drawing a lot. So basically, augmentation is doing something like this. Ideally, it's meant to. I think augmentation is basically just meant to increase your data size in a lot of instances. It's meant to increase the data size, and it's meant to help you with um, situational things. It helps your model to see more scenarios, but it's of the same picture, but it helps it to see more scenarios. Let's say you have something like this. Let's say you're lacking in training data, for example, and let's say you have maybe you only have, let's say, two pictures of, oh, I was about to say a dog, but my drawing's not going to be good. Okay, let's say you have only two pictures of a happy face. Let's say one, and let's say two. Just imagine this is a happy face, please. let's just take this. Let's just take this as a happy face. All right. Let's say you only have these two, and these models. To be honest, if you don't have enough, it's not going to be very nice, and you actually need more training images. What you could just do is, just do the augmentation, and you could have one face here, and another face. It could even be something like this. It could even be something like this. At the end of the day, that's still something. And now you have four images from two. So that's one of the things that augmentation does. But the main reason why I'm actually doing this augmentation is, like I said, because of something like this. Some players might just write their X's like this, and it's not really ideal. They could just put their O here, for example. Yeah. And if I only train it on something like this, then this might not be, this might not really help the CNN to determine what it is. All right, so there we go. So what I'm just doing here is I'm listing this. This is basically just showing one of our images, the first one. And first off, okay, I'm gonna get this, and this is. Please put in your own address if you're following this. You can just put in your own address, and this should ideally work. But this is mine. That's why I did this. Really, I shouldn't be doing it this way, but just to make things a bit faster. All right, so we have our matplotlib to help us to show the image, and this is one of it. All right, so the next thing that we're going to do is I'm just going to show some of these images. We have our batch size of this one to be 32, image height to be 180, the image width will be 180, and we're going to use Keras to load the image from our directory. That's the whole point of this guy here. All right, and you can see RGB. I don't really think this is necessary because I mean this is just basically black and white, but we'll just put it there. Anyways, um, to be honest, if you don't put this, if this is red, green, blue, by the way. To be honest, if you don't do this, it might not really matter because all that we really need is if we have something like this, we just need the numbers. The colors don't really matter. The colors don't really matter if you have, let's say, something like 0. We just need the numbers of these guys here. So, the RGB is basically just more information, but it does make things seem nicer. But yeah. All right, so we have our batch size, we have the image size, and validation flag. We're gonna send that as one. So you can see found 220 files belonging to 2 classes. All right, so we're just basically just loading this into our train.ds, and it's going to be very helpful for us to do this in batches. Like I said before, this one is in a batch size of 32. All right, so we are going to be loading them in batches. So we might not get the same thing that we are showing now. So for example, we have something like this. This iterated. That's why I named this one batch iterator, and this is our batch. All right, we use the next function right here. So this helps us to plot just 4 of them. Yeah, 32 of them, but we'll just plot 4 of them. Okay, that's this guy here. Just choosing 4. Anyways, if I do this, you can see this is x0x or x00x. If I do this, you can see how this is going to change. Yep. So basically, we're just loading this, and it's basically just doing it as a batch of different images. All right. Next up is our test folder, and basically this is just a copy and paste of this, to be honest. All right, and the class names that we can see in our training data set is O and X, which is very good. So we can move on to the next part. All right, so this just helps us to plot some of the data, and this shows us a class, so we can see that everything correlates well. So this is our X, O, 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 O. Now this would have been in trouble if this was O and then this was X, but now we can see that things going well so far. Okay, this one's not really compulsory to put, but it does help us show that we're still on the right track. Next up, we're going to show how the data augmentation thing works. So, okay. Oh, sorry, now I remember why I did this. Okay, so this one right here is our normal, O. It's just one image that we chose at random. And just to show you how the whole thing works, we have our data augmentation variable that contains this. And what we're saying is, I want you to flip there to be a chance of you flipping the image, to flip this image horizontally and vertically. You might do it, you might not do it, and that just shows in this particular one here. This one's random rotation, but this is the probability of it doing that particular action. So this says that there's a 20% chance that it's going to be rotated. So That's why we have these right here. Okay, I forgot to almost skip this part. So this is just to help us to plot this. All right, so you can see that right here, it's the same thing right here, but just in different directions. So this helps us to increase our data set, like I said, and it also helps us to see more situations, especially for this our case here. What do you think of it? I think I should make this a bit. I think I should make this a bit thicker. So this seems nice. Ah, no, that's better. All right. Okay. So I did have some trouble trying to plug this into where is it? 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 Okay, I had some trouble plugging this particular augmentation uh, method into our model. I think I'll probably need to do more research on that. I think there's something about it's being depreciated, or I don't know. I just couldn't find a solution to it. So I had to go through this way, and what we have here is image data generator. All right. Now, what I did was to these are different things. They are quite similar to these guys here, but just in different formats. All right, so we have width shift, height shift, shear range, zoom range. This zooms in and out. This is 50%, 80%, 80%. This is just to make sure that we do see most of these situational things. I keep on repeating this because it's actually quite important. Because I remember when I finished with this, and when I just created, like, I think the second model or so. I tried when I drew the shapes this way, the normal way. The model performed quite well, but when I was doing something like this, trust me, it was not giving me the results I wanted. So that's why I keep on hammering on this. So sorry about that. But here we go. We have the train um, data generator. That's data gen. All right, and what we're going to do right here is we're going to make this a flow from directory, and we're just going to take this in into that. All right, so that's our batch size, and class mode is binary. Our size is 180 by 180, and it is quite important for these 180 numbers to be sorry for the 180 number to be consistent throughout. So we even have it right here, because if you don't make them consistent, there is a very very high chance that you're gonna have some annoying errors. But yeah, so we have this, and then we have a train DS. Okay, this just shows us, yeah. So this shows us our data set object. Now we have our shape here is none 180 by 3. That's because we had the RGB stuff. So that's 3 channels. That's 3 channels right there. Type is flow 32. What else is there? Okay, yeah. That basically just shows us like the details of what we have right there. So now on to the exciting slash I'll just say exciting part. I was thinking of another word there, but let's go on. So onto the building and training parts. What we're gonna do is we're gonna import these guys. So we have a sequential. So basically, we're just gonna keep on adding. We're gonna have this sequential right here, and what we're gonna be doing is we're just gonna keep on adding our layers. So we have our convolutional layer. We have our pooling layer. I think I drew those ones. Okay, convolutional layer, pooling layer, dense layer. This basically is when the whole thing is just a normal neural network. Flatten is what helps us go from something like, I think I drew it earlier. Where is it? Okay, it also goes from something like this into something like this guy. So that's what flatten does for us. All right, dropout. I don't think I used this. Don't think I used this earlier on. We'll see. Anyways, so we're going to add this. What we're going to say is for this guy here. So the first thing that we're going to add is our convolutional layer, and what we're going to have is we're going to have 16. We're going to have 16 filters or 16 kernels, all right, to do the whole sliding thing. And this one right here is going to be our stride. So, okay, if I didn't say that earlier, so basically, if we have something like this, and now I think about it, I think this is too big. All right, I think this looks more nicer. Okay, that's manageable. So we have something like this. So we have, let's say we have like a filter that comes here. Let's say we have like a filter that comes here like this. Let's say this is one filter. So if we have the stride of one, the next thing that's gonna happen is we're gonna have, what color is this? All right, okay, let's have a colorful one. All right, so next up is going to be something like this. It's just gonna move one stride. That's one stride right there. And if we have something like, and then the next stride is going to be something like this. So you can see it moves and moves and moves, and then it gives us like a representation. So that's this stride right here. That's this guy. And the 3 by 3 is the size of our kernel. Like I said earlier, most of the kernels are 3 by 3. So this is 3 and this is 3. To be honest, it's not compulsory, but I mean that is what is quite popular. All right. So we have ReLU as our activation function, and ReLU is very popular. So let's say we have something like this, for example, just to share a brief thing. So we have 1, 2, 3, and then this one be -1, -2, -3. So if we have something like -1, if we have, let's say, something like -1 as one of the boxes, it's not going to be it's not going to be considered. It's basically going to drop it. It's going to think that it's just basically going to convert it to zero. So already, let me just change this right here. So already is going to be something like this. At the end of the day, it's going to be something like this, and then this goes up. So if you have a 1, it goes to 1. If you have a 2, it goes to 2. But then if you have a -1, 0, -2, 0. So basically, if I'm applying something like a value to something like this now, just for example's sake, as this is -2, this is -2. What's going to happen is we're going to have something like this. We're going to have 1, 2, 0, 0. So that's what Red does. Very nice activation function. It's quite popular. All right, so moving on. Next up, okay, I don't think I've said. Okay, I think I mentioned this. Yeah. The input shape that we're gonna have is 180 by 180 by 3. Um, it's this is okay. This is not with this. Don't make that mistake. This is the size of our filter, while this is the number of channels that we have. Remember, every picture has red, green, and blue. A red, green, and blue channel. So basically, that's what's right here. All right. So next up, we add our max pooling layer, something like this. This is what I was trying to explain right here. So we put this in, and then next up, we add another layer um, of convolution. So that's going to have 32 filters. That are 3 by 3 in size, with a stride of 1, activation, same thing with value. And to be honest, these numbers, I mean, you could use you could do you could have your numbers to be anything basically. It's not like it's a fixed thing, but then popular you do have popular frameworks, or will I say, I've forgotten the word now. I've forgotten the word now. It'll probably come back to me later. But you have like regular frameworks that have these numbers that are pretty much standard that work quite well. But I could change this to 33 and it's going to be fine. But some of those are quite sensitive, like this one for example. Okay, and the reason why this isn't repeated here is because this was our input layer. So this one shows our input layer, while these ones are the hidden layers, technically. All right, and we have a flatten. So like I said before, it converts something like, okay, oh yeah, here we go. Right, so convert something like this guy into this guy. All right, so our flatten, and then we have our dense layer, and then we have basically our outputs right here. So the sigmoid, just gonna come down here. So this sigmoid right here is going to be, let's bring that up. So we have the sigmoid function. It's quite similar to the, looks a bit more like the tan h function, but it's not really that. All right. Yes. So basically, this, for those of us that are quite familiar with these terms, I mean, we all know that these ones are. Okay, no, wait, no, sorry. A lot of us might know that this one's used for, you know, for the logistic regression and some other things. So it's quite useful. So that's what we're using in this case. And okay, let me just pull up the ready function in case my drawing was too ugly for you. So we also have the ReLU function. This one's also used in a lot of things. So we have the sigmoid, we have the ReLU, and we use them quite interchangeably. Um, yeah, we use them quite interchangeably, but some are best used in other situations than the others. All right, so next up we have our optimizer. So this one right here is to optimize our model, and here we're going to have the Adam optimizer. Let's see if there are other ones. I think this one shows it. Okay. We have metrics, loss function. Okay, just going to use this guy right here. Okay, so we actually have a lot of optimizers. We have the Adam. Can't remember the other ones off the top of my head. So let's see. We have Adam, Adam W, SGD, something like C. So we have quite a good number of them, which are quite nice. All right. So we have class Adam, implement Adam, and run them. So this is the guy we're using right here. Okay. So, okay, I think this is a part that I may be missing. Okay, so okay, this is just because this is a binary classification. I mean, we are only classifying X and O, so we don't really have a lot to classify. All right, and this is our summary right here. So you could just go to this, and this is 178 by 16. That's from this guy right here. And the reason why it's not 180 right here is because you do tend to lose some of the information while you're doing this. Remember, like I said, this is a filter, and when the filter does this, you tend to lose some of your pixels. So these are called pixels for those of us that might not know. Yeah, we do have that. All right, there we go. If we really wanted to make this the same, there are some padding techniques that we can use, but I'm not going to touch on that. So everything looks okay right here. That's the parameters and okay. And for this one, this is basically just a way for us to be able to track and recognize. I'll use the word recognize. It basically helps us to track the checkpoints. So in the end, it helps us to know if the accuracy is improving or if it's if it's reducing. So for example, now we have when we fit the whole thing into this guy here. Okay. Okay, before I go into that, we have the model fitting the train generator that was from, where are you? Yeah, right here. So our augmented data is going right into our model, and epochs 10. This is a very, very low amount of epochs. This is basically the amount of times um, that the model does like its whole training step and everything. This is very, very low. So, but I just reduced it to 10 because I just needed to be fast with, with the video. But ideally, when I was training the model, I used 200 of these. I've done more, but I just used 200. So quite some time. Ideally, 200 should not be taking that long for me. It did take quite a while, but shouldn't be taking that long for me. But I have problem with setting up my GPU with with TensorFlow. I don't know what's going on, but I'll probably need to check that out later. So okay, let's see. I think I was about to show something. English train generator tensor call back. Okay, yeah. Oh, I think I was about to say this. All right. So this was the model that I saved this on before. This is where my 200 epochs are, but I did save one right here. Let's see. Yeah. So this is vtests right here. Probably save another one just to use it to show you guys. Okay. So, like I said, we have our validation data, and as you can see, it shows us right here. Okay, I'm just gonna run this once more. So I have 1/10. Okay. So ideally, this shouldn't take too long, because if I made this 200, I think we'll be here for quite some time. Okay. So for, I don't know. I think it's a called CUDA. So we have a CUDA 2K. I'm still having issues with it. I don't know why. Having issues with it because I do have a GPU, but it's not really helpful in this instance because this should be far faster than this. So, anyways, you can see the model being trained right here, and we have our loss, we have our accuracy. Let's see if there's a way for me to do this right here. Okay, it's on the same line. Sorry. Alright, so we have our loss to be 0.7 and we have our accuracy to be this. So ideally, our losses should be going down. Our losses should be going down, and our accuracy should be improving. So if it's not improving, then something is wrong. Okay, this is just a few steps. This is just 8 or 10 steps. So that's why it's not showing really great right here. Okay, so that's it for our model. I think our model is ready, and what I'm going to do here is for my evaluation, what I did was to actually use the drawings to get that part, and just gonna come here with my stuff. Just gonna come here. Alright. So I'm just going to run my program once again. We're going to try and get this. The reason why this error is here is because you can't find any file like this. Okay. So let's just say X, and so just have something. Bear in mind, there's a very high chance this is going to be very incorrect, but there's a very high chance that the model is going to guess this incorrectly because we only trained it 10 times. So if I play this, let's play this. I'll explain this one later. Alright, so we have our canvas 0, 0 right here. Hopefully this one comes up fast. So this is our guy. So that's our guy right there. Okay. So if I do this right now, it should show us this. Yeah, there we go. Right, so we're resizing this to the ideal size. We're showing this, and okay. Next part is we're going to load the model. Let's classify H5. Okay, so let's do this right here. And we'll save the model. So this helps us save the model right here. And hopefully this is correct. Don't take my word for it. Okay, what's going on here? Oh, I used, okay, this one's not existing yet, so I'll just change this one to 0. Alright, let's see what's this is, bro. Okay, it did say something nice. Image is X. It's not really sure because I mean this is 0.5, so it's not really sure about it, but we'll take it as it is. Alright, so it says this is X and we are correct. So that's just to show us how this works, how the whole model thing works. Alright, so how this happened, we read this guy, we resized it, showed this, plot the show. Okay, so the reason why this is the reason why we're expanding the dimensions, this is numpy to expand dimensions. The reason why we're expanding this is because TensorFlow does not want us to use, TensorFlow doesn't really want us to just give it one image. It wants to read the whole thing as a batch of images. I remember we had a batch right here. Let's see, where's the batch? Where's the batch? Yeah. So we have something like the batch size and everything. So TensorFlow prefers to work with batches in this scenario, and that's why we're just doing this. So this 0 is just there for, it's really there for decoration, to be honest. But without it, it's not going to work out. So we're going to do this. So we're going to print this guy. You can see. Let's see, I can't do the show. Yeah, I think so. Alright, so we have images X, that's what it's saying, because the score that we do get is above 0.5. So if the score that we get right here is above 0.5, then it's X. If it's less than that, then it's O. So this guy is X here because this is 0.53, and that's how we do it. Let's just delete this guy. That's not necessary. Okay, so basically that's just to create the model that we're going to use for our game. All right, now moving on to the next part. All right, now this part might be a bit confusing because you do have the whole Pygame thing is not really that complex. I mean, you do have to do some basic arithmetic, but nothing really complex. But just some numerical reasoning, and you'll be fine. And just get familiar with it. This is my first time using Pygame, so it might look a bit weird to someone that's quite experienced in it. But yeah, I think I used a well look too many times. I think that's something that I could have actually optimized or tried to reduce. But hopefully it's good enough for our first time. Now we have while loops, we have and the whole recursion thing, my goodness. I mean, that kind of thing takes Takes time to actually learn it. Still trying to get my head around it, but just gonna say like just gonna give an overview of it. All right, okay. Let's get back to business. Enough talking. So first things first, we import our dependencies. We import the dependencies right here. Pygame, this, and everything. All right. So we use this to suppress our errors, and I'm not going to give a Pygame tutorial because it is quite it is quite long. But I'll just do my best to just say what I could say. So for the first thing that we'll need is to set our colors, and these are our colors right here. For those of us that use HTML and CSS, we might be quite familiar with these guys. Quite familiar with these numbers. I had to Google these because I don't know any of these on the top of my head. I had to Google them. But there we are. We have blue, black, green. Okay, I don't think I used green for anything. Okay, did I use it? Okay, I think I did. I think I did. Um, Next up we have width and height. So this width and height, that's for. Okay, I think I'm just gonna run this so that it'll be easier for us to see. So the width and height is basically for our for this canvas right here. So that's our width and height. So this is 600 by 600. So the line width is 5. The board rows, we have 3 rows and we have 3 columns. 3 columns right here. Our square size, it will be the width of this divided by 3. So that's why we're gonna come up with this. The circle radius is our square size divided by 3. Our circle width is 15. Cross width is 15. Alright, so we'll see the importance of these guys later on. Alright, so the first thing we just need to do is set up our screen right here. And this is our whole screen. So this is 800 by 800. Oh, sorry. So we have 800 by 800. So that's why this is this big. Alright. Then it's a caption, Tic Tac Toe. That's this guy here. So basically the screen is filled with black. So ideally it might not look like it, but the screen is black, and this is basically just put on top of it. But trust me, everything here is black. Basically it's black. So this guy is just on top of this guy right here. Okay. So the next thing we did was to create. Okay, I think I might need to pause. I need to pull this guy right here. I'm going to do is this. Okay. Let me see if we're putting this. Can I get this guy? Okay. Okay, so what we have right here is we know that our board is going to be something like this. Our board is going to be something like this. So basically we need a representation for each of the boxes that we have right here. So what we're going to have is a 3x3 matrix. 3x3 matrix to show that, and that's going to be basically used in the back end to do the whole thing. So we have MP0s, board rows, this. So if I put this in my, let me just show this in my Jupyter notebook, and let me show you what it looks like. So I do something like this. Oh, sorry. Let's just change this guy to 3. And I'll change this guy also to 3. Okay, I don't think I need this. Right, so you can see here that we have something like a Tic Tac Toe board. So this is going to represent this represents this, this represents this, and this one represents this. So basically that's what we are doing in this case here. All right. So next up, this one right here is to draw the lines. So this is a rectangle function, and what we have right here is we're going to put this on the screen. So draw our lines. You're going to see me spamming this a lot because the thing about Pygame is you have to put the whole thing on a while loop so that everything is quite responsive. And if you if you tend to put things in one place, and then if it's not in another place, you can tend to lose some details. You can tend to lose some details. So I just ended up putting this draw lines function almost everywhere. Almost everywhere. I do that's not standard, but that's what I just used to solve the whole line disappearing. Because in one place, if I put the function in one place, well, let's say for example, if it's so like this now, if it's showing in one place, and then let's say I just click a button, I just click something here, the whole thing just could just disappear, and then you just have a blank canvas. So I was having that problem a lot. So I just tend to put the draw lines in different places to solve that problem. But we'll just use that to get along. Anyways, we do have pygame.draw rectangle right here. Okay, so this helps us draw the lines, and it says that from 1 to 3, these are bud rows. I want us to draw. So basically, this is for these lines here. These lines. So this is this function. I won't get into the details, but that's how it was. That's how I got that right there. Okay. All right. So this function right here is our circle function, and what we're doing is, or the concept I used in this one was like this. So okay, I'm just gonna make this big, so I can make this guy a bit bigger. Okay, so if we are drawing, you know that if I just click this once, that's one circle. If I click this again, that's another circle. So if I want to draw my name, all that's just happening is me pressing this uh, very, very quickly. It's just a continuation of circles, and you can see. So that's right here. So it's basically the same thing as this, but if I do it like this, you can see it's the same thing, just a continuation of circles. So that's what that function is for. That's the idea behind it. So it's just doing this whole process faster. That's what drawing is, or that's what I use to create the drawing function. And we can use the Pygame, draw the circle, and this is going to go on the screen to be passed on from here. Yeah. And our XY. So this XY is going to be the position of our mouse, and when we click, so that's going to be shown later. So the 5 right here is going to be the, I can't remember if that's the diameter or the radius, but yeah, it's just the size. Can't remember exactly. Let's see if I can get it. Radius. Yeah, I think it's radius. Yeah, radius. Okay. So moving on, draw the box indicator. And what I did for that one is so that we remember what box we're on. That's going to be this guy right here. So you can see that this part has turned green, and it's just showing us that we can draw on this guy. So you can see right here. Yeah. So this is the function to draw this box around there, and if we play, go on, so I can choose another box right here. So basically that's what that is. So our top left, top right, bottom left, bottom right. So we have our X, square size, okay, and that's how we got those guys right there. So these guys, basically, if we have something like this now, so we have, okay, I'm just gonna scroll down to get any more space. I'm gonna reduce this guy. Okay, so let's say we have something like this. So we have something like this, and let's say this was the one I chose, for example, now. So I'm gonna have this box right here. So how I got these guys, it was a bit of a struggle when I was trying to do that, but I did come through. Let me see if I can get my stuff later, because getting the right formula could be quite tricky sometimes. So I calculated this guy here. So we have our top left, top right, bottom left, bottom right. So if we do x, so x is, okay, x is the x coordinate of our mouse, and y is the y coordinate of our mouse. All right. Am I saying it right? Okay. So if we have our x to, if we have our x to be square size. Okay, no, I think I'm making a mistake. Sorry. Just to check something. Okay, so now I figured out why I was a bit confused. So it seems like I was correct, but I just didn't see. I just didn't remember a few things. There are a lot of variables, so it's quite difficult to keep up. All right, so here's how it works. Basically, um, we have this, right? Okay, so we have our x and y. We have our x and y variables from our mouse. That comes from the mouse input, so it's going to range from anywhere between 0 to, what's our square size again? I think our square size should be, I think our square size will be 200, because that's 600 divided by 3. All right, so range anywhere between from 0 to 200, and if we have something like this, right? So here will be 0, 200, 400, 600. Now, it's the same thing here. Will it be that way? Not really. I think it's more like this. 400, and this would be, so this would be 600, 0. Okay, that looks better. All right, so let's say we click on this one, for example, now, right? And let's say our x right here is, let's say 118, and our y is, sorry, x will be, yeah, okay, let's say 118. And let's say our y is 130, for example, now, right? So for us to know that this is the first box right here. So let's say for this one, we can just say this is row 0, row column 0, 1, 2, 1, 2. So for us to know that it's this particular one, what we'll just do is we'll use floor division. So you're gonna see the floor division right, this symbol a lot right in this script. All right, so what we're gonna do is we're going to do x divided by our square size. So this will help us locate which of the boxes that we're dealing with. All right. So if we do this x divided by our square size, what we now have is, so let's say this one's 118, right? So, sorry. Okay, let me go to my Jupyter notebook. I think it's better if I just show you. So I do, let's say something like 118 divided by 200. That will give us 0. So now this will give us 0 right here, and this will give us 0 right here. So that shows that this is it. But the reason why it was a bit confusing to me earlier was because of this guy right here. Let's see what's the where are we? Okay. Yeah, you can. So many things to scroll down. Okay, here we go. So this is our x, and this right here is our y. So I was thinking that it was going to be left like this, but then I had forgotten that I did this later. So this is going to be our input, and this is going to actually help us to locate, where the location of the what we're taking is. So if we're going for row 0, column 0, what we now have is, okay, we have our top left, top right, bottom left, bottom right, right? So let's just go here. Top left, top right, bottom left, bottom right. Now, if we plug in any of these guys into it, you'll be able to see that we're actually able to use the results to plot our lines. And okay, so just for example, the top left, let's say our x becomes 0 like here, and our y becomes 0. What's going to happen is, so x times square size, so this would be 0 times square size, that's 200, that's 0. And we do y times square size, that's 0 times 200, that will also be 0. So we start 0 here. Now, let's say top right, for example. Now we have 0 times 200, that gives us 0. And then we have y will be 0 times 200. So you can see this one is plus square size. All right, so this is plus 200. So that gives us 200. So this one right here is 200. Now this took me quite some time to actually get the formulas, because they can be quite tricky to figure out. So if we plot this guy, let's say this is this right here, and I change this to this. So we go from top left to this guy, and we follow these formulas that I brought up. You can see that we'll be able to get a box. We're able to get our box right here. So we draw from top left to top right, top left to bottom left, top right to bottom right, and bottom left to bottom right, basically. So that's right there. All right, next up. Now this one is going to be a little bit scary, but let's go. All right. So we are going to have to draw figures, and basically this one's meant to just typo there. Did I get that right? Yeah. All right. So this function right here is to help us to draw the figures for the letters in the boxes. So basically, it's going to help us to draw the letters, whether it's O or X, and it's also going to help the algorithm to draw the letters too, right? Okay, so this drawing, we're going to see this one later on. There's a reason why this is here. So drawing is going to be set to false. Canvas state is going to be set to unlocked. Now, the reason why this was put there is because I needed to make sure that the player finishes playing in a particular box before they go to another box. I don't want a situation where the player draws in one box and then draws in another box before the algorithm plays its move. So basically, that's why that's there. So we have next up we have selected row, selected column. These ones are put to none at first. Okay. Then the next step is I will see the reason why I'm putting these variables later on. Alright, so we have button the rectangle button. So you can set a rectangle to be this, and the color I can't remember what color this is, to be honest. I think I'll probably need to check online. But that's the color right there, 200, 200, 200. If you're familiar with HTML, CSS, you might probably know one of these colors. But I'm not really good with colors, to be honest. All right, so we have fonts. We're going to use Pygame the fonts right here. So read this right here is the size. All right, and we're going to put play as shown here. So this is basically our button text right here. Okay, that's our button text right there. So another thing that we're also going to consider is the button clicking. That's quite important. Remember I said that the some of the boxes are going to be locked. Not some. The boxes that the player clicks is going to be locked until a button is clicked, so that the player doesn't draw on other boxes while he's still drawing. So the reason why I put this is because if the button is right there, and let's just say, I think you can hear the clicking sound, and let's just say I click my mouse once. If this isn't there, this is going to read this as me clicking it like 100 times. So you know how fast these things can be. So you know how fast computers are these days, and how processing is quite fast. So it thinks I'm pressing it for. It thinks I'm pressing it like 1,000 times, but I'm actually only pressing it once. So this is actually to make that a bit slower, so that we can have a more realistic, more realistic input. Because if I just do a quick click like this, it's just in that just in that just in a small space, it thinks that I've clicked it about 10 times. So all I'm trying to say here is once this time has elapsed, this is I think this is milliseconds, yeah. All right. So once the time has elapsed, then it can allow another click. So ideally, I'll only click once, and that will be my input instead of it thinking I've clicked like 1,000 times. Okay. Now we're going to load our model. I think I said this before. This was the model I did right here. Okay, this was one we just used for educational purposes. Right. So that's my image classifier. And here we go. Okay. So next up we have our row center and our column center. So this is right here. Calculate the row center. Okay, put a comment right there. So draw with O and okay. So for each of the boxes in our Tic Tac Toe game, we're going to be doing all of this. We're going to be doing all of this. All right, and basically what this, I think we'll see the effect of this one later. But anyways, we are going to do this right now. So basically, we will be player one. So if the present board, is 1 and our player is also 1, then that's going to be us. That's going to be us. So remember I showed this earlier. Where is it? Okay, right here. So if this is a 1, then it's going to be a player. But if it's a 2, then it's going to be the algorithm. So basically, 0 means no one is there, 1 means it's us, and 2 means it's the algorithm. So as it's 0 now, that shows that no one's there. Okay, so if we are in a particular box, we are going to use a while loop for this second part. Now, if we're in a particular box, then what needs to happen is for us to use a while loop to try and display the things that we're going to be putting there. So let's say we have something like this. I think it would be easier if I just try it out. Pygame uses a lot of while loops, so this whole thing might be a bit confusing at first. It's gonna be quite difficult to get your head around it, but I'll just do my best to explain as best as I can. All right, so we have our O here. Okay, let's see. Okay, so this one right here now is 0, 0, 0, 0, 0, 0 because nothing's there. So if, let's say my shape is 0 now, and I do a 0 here, then this turns into a 1. But if the computer plays X, this turns into a 2. This is still 0 because there's nothing there. So X, 2, 1, 0. All right. So this was put. So that's basically that's basically an explanation as to why this player has to be 1. All right. So if the player is 1, all right. If the player is 1, then what we're gonna have is while true, the current time. We're gonna use this one to get the right time. We'll say that for event in Pygame, the event.get, if the event type is equal to Pygame.quit, then we're going to do this. And the reason why this is there is because we'll need to actually be able to quit the game if we don't feel like playing anymore, or if we just want to quit it. So I'll just put X like that. So that's the whole reason for this guy here. Oh, I made a mistake. Okay. So let me just run this one again. All right, so we have so basically this is where the whole drawing thing comes into place. Now, if the mouse button is pressed down, all right, the drawing from here is going to be set to true. And once this is set to true, X and Y is going to be our mouse position. All right, this is going to be our mouse position. And the canvas state now is, if the canvas state is unlocked, then we need our X to be the selected column and the Y to be our selected row. Remember when I talked about this, that this helps us to get, the floor division here helps us to get our location that we're on. So that's right there. And what's going to happen now is the canvas state is going to be set to locked, and that's because of this. So if I do this, for example, now, so if I want to draw X and I mistakenly go over line, you can see I'm not able to go to any other else. So if I click anywhere else like this, can't do anything until I finish from here. All right, and this is still locked. This is still locked right here. So this is what we're going to use to unlock it, which is trying to say that unless we finish drawing, then we cannot leave this one. Okay. So mouse button up equals to Pygame the mouse button up. Okay, so the drawing is to false. Now that's when our mouse button is up actually. All right. Then if there's a mouse motion and if we are drawing, remember our drawing needs to be true when the mouse button is down, then we'll get our, okay, I think I should have, okay, I think this should have been this way, but I'll probably need to review that one later. Okay. Let's see something. Okay, let's continue. Alright, did I make a mistake somewhere? Okay, so if the selected row is not none, selected color is not none, and x is less than 600 and y is less than 600, then we can do the drawings. So the reason why for all these conditions is because for this ones, if I don't put this there, it does work, but if we end up clicking outside of this bounding box, then we tend to get an error. So that's why I put this there. Then if the selector row is not none, that means if we've clicked any of these canvases or any of these boxes, then we can draw. So we're just going to use this one right here. Now, this is our, okay, yeah. So now this is our Pygame draw function for the circle, all right? And this helps us to like do it continuously, right? So we do canvases, selected row and column. Now for the canvases, I'm just going to go to the end a little bit here. I'm just going to jump the gun for a little bit. Okay. So for the canvases, we can see that we have this right here, and if I bring something up, where is it? Okay, so if I bring up the canvas in Pygame, let's see if we can bring it there. Okay, I think that's what it is. Okay, does it look like E? Okay, I think we'll just look at this guy here. Okay, so this is only a documentation, but okay, basically it's just like each of these boxes are on their own. Basically that's all the canvas is. So you know how canvases are in painting, so it's something that you draw on, and that's basically the whole thing. So we have 9 of them right here, and we have 1 here. So this is 0, 0, this is 0, 1, 0, 2, and like that. All right, so we have, I did the list comprehension, so this might not really look too straightforward. We have Pygame on the surface and this, all right? So basically it's something similar to this, guy right here. It's quite similar to this, but yeah, it's quite similar to this. So this will be our canvas, and we'll have each of them for each of, we'll have each of them for each of the boxes. So we have one for something like this for our back end. That's the real board, the representation of the board, and we also have a canvas just for the display. But I tried doing this for the canvas, but I was getting some errors, so just had to go through this route. So here we go, right here. You can check it out later. Okay, going back to this guy. Where is it? Okay, so canvas state is locked, and okay, I'll use quite some time. I think I'm gonna start rushing. All right, so we have the selected columns with this. Canvas state is locked. All right, so basically this just helps us to draw in the canvas that we selected. All right. So next part is going to be our button, and this is just going to help us do the actions that are necessary for the recognition. So we have our mouse position, the mouse click right here, and this right here says that if the mouse is colliding with what is it? The mouse is colliding with this guy, make it light gray so you can see. If my mouse comes here, then it's going to be light gray. Sorry, light blue. I don't know why I said light gray. Yeah. Okay, so if we click on this, now, if we click on this, then this disappears. And now we can start again. And then we can go to another place and, just continue. All right. So here we go. If this is clicked, now if current time is if the current time minus the last click time is greater than or equal to cooldown millisecond, then we can continue. So basically, this is just a simple way of just trying to say, please do not make us, click the button more than once every second or every half second, something like. So that's how it is. Now we have a file name. So for this part here, what I did was to now we have each of our canvas here, right? Okay, let me just show this right here. So if I draw something like this, let's see if I draw something like this, we have this canvas. Now, once I click on this is going to get saved. This right here is going to get saved, and it's going to go through our model. The model is then going to predict what it is, and if the model says that it is the same thing that we chose, when if this model says that it's the same letter that we chose when I remember the formal menu screen that we had to choose between X and O. If it's the same shape that we chose before, then it's going to be like, okay, yes, that is your shape. Because now, if I draw something that's not the right thing, it's going to say that apparently, okay, that's a part I should have worked on, but it's going to reject it. So if I say, oh, now ideally they should reject it, so you can see it's going to wipe that off. It's just going to take away what I drew before, and it's going to just put a new canvas on it and say, that's not what you chose in the beginning. So, like I said, once the button is clicked, it's going to save the file. It's going to save this in our file. All right, it's going to read the image, then it's going to resize it. Remember, TensorFlow can be very particular about how it wants its images. All right. So we'll predict it. Now, once we get our shape, so remember, if it's, I think we got to like 0.53 here. Yeah, we got 0.53. So if it's greater than this, if it's greater than 0.5, then it's X. If it's less than 0.5, then it's an O. All right. So what this one is just trying to say, this is probably just a failsafe. Now, if the shape that we draw is not the player's shape, then we need to, put the canvas to a reset. And once that has been fulfilled, we can break and everyone's happy. And next thing we know is that this right here is going to get unlocked. So this was not going to be unlocked unless I play. So if I do something like this, I don't think it's even help. Let's see if it's work. Oh, it's worked apparently. So apparently the model didn't predict that well, which is not good, but just get the gist of it. Okay, let me try putting O again. Yeah, okay, that's working now. All right, next step, Pygame to draw. So this one right here is our rectangle. It's the normal one. That's this regular right here, the blue one right here. So if you are interested, you can just look on how Pygame works, and basically that's how it is. It's not really complicated, but it can get a bit. It can get. It can be a lot. It can be a lot. But yeah, just try to rush through this. Okay, next up we have screen update. So this screen update, basically what it does is most of the time you actually have to put this in a while loop, because this is going to update what's being shown on the screen. So if this isn't done, or if this isn't put in a while loop, then you're just going to see it's pop up once and then that's the end. You're not going to see it again. So it has to be in a while loop, which is why um I did have problems with arranging it, because I think I might have repeated some lines of code somewhere, but I can't remember. Anyways, so we'll next up we'll show and update the canvas drawings. Okay, just to say, this is drawing the button text, and that's this guy right here. All right, show and update canvas drawings. So for row and this, for row and this. So if it's not equal to 2, then the screen is going to update. It's going to update the canvases that are being drawn. So anyone that the algorithm draws on is not going to be updated by this guy. So that's why this is here. That's why that's there. So remember I said this one, I just put it anywhere. So I'm putting it here too, so that we don't lose our lines. All right, same thing with this guy. And our Dropbox indicator. This one right here is just to update, keep on updating the surface, and that's where that is. I'm not sure if it's compulsory, but it just felt right. Okay. Now, another thing, if the board is equal to 2. Now, if the board is equal to 2, then that means that's the algorithm playing. So it's trying to say that if the computer's shape is X, because if we choose O, then the computer shape is going to be X. If we choose X, the computer shape is going to be O. So basically, this is just like for the computer. Okay. So we'll draw a line on the screen. On screen, and let's see. Okay, so we're drawing this line on the screen and cross width. I'm not going to get into the details of how I calculated these, but you could just go through it and see how that came about. So I'm just going to draw the line. We have start position, this guy here, and the end position. So it's something like okay, if I quit this, for example, I'm just going to do that so that I can show you how it looks like anytime from now. Okay, so if I choose this guy and I draw O, delete yes. So this is how it's going to show up. So it's going to show up. This 20 right here is just this space, these spaces that you can see. If I don't put these 20s, then what's going to happen is the X is just going to start at this point, at this vertex here, because this is the whole canvas, and I just needed to put like a bias or something like that to ensure that, that it looks more natural, like a normal X. Okay, so this is for one line. I think this should be for here to here. So we have one start position and end position. Then for the second line, we have one start position. That's this one right here. And we have the second end position. So you could take a look at the arithmetic that I did. Very tricky, very tricky. All right, and for thankfully this one wasn't as tricky. For the O, we just just put this guy. So now we see the importance of this guy right here. Where are you? Where are you? Where are you? Yeah. So our row column center and our column center. Okay. So that's it, and usual just put update to help us with it. Okay, so we're getting somewhere. Now, for us to mark the square, thing is ideally it will be everything is so interwoven. That's why some parts might sound a bit confusing because this part now is in some places and everything's also interwoven. But I'll do my best to keep on trying. All right, so this one right here marks our square. Remember, I said we have the board that's the back end. This is basically the real board, or the representation of the real board, and this helps us to. This right here helps us to mark if it's going to be a one or a two or if it's just going to not be anything. So that's what the mark square is for. So you can see board rule is going to be plain. Anytime you see board, just put this image in your mind. Sorry, not this one. Just put this image in your mind. All right. Because we fake and raw image. Yes, just put this in your mind anytime you see board. So let's see board. Okay. Now, the available square is, like I said, if nothing's there, it's going to be represented as 0, right? So this helps us check which one you have, which squares are available, and if it's not available, it's either going to be 1 or 0, 1 or 2, sorry. And this one also helps us check if the board is full. So for each of them, we're going to check board, and if it's equal to 0, check plus 0. So if any one of those ones are 0, then we're going to return false, and we know that the board isn't full. So this helps us determine if the whole thing is like a draw, and it's also useful for some other things. So next function, a lot of functions. Next function that we have, we're going to check win, and basically what this one is saying is, so we have 4 things here, because the ways you can win in Tic Tac Toe is if let's say these 3 are the same, these 3 are the same, or these 3 are the same, or the columns are the same, and if columns are the same, and then you have the diagonals being the same, or these diagonals being the same. Now, if those guys are the same, then we know that, then the game has been won. So that's what check win here is for. So this one's for the columns, this one's for the rows, and this one here. Couldn't think of another way, but I just went with this. So we have 0, 0, checkboard. That's this position. If this one right here, and this one right here, and this one right here are the same, then return true. If this one right here, this one, if that's the same, then return true. So, and then these ones are just for the rows. If any of the rows are the same, then we're going to return true. And if any of the colors are the same, we're going to return true. Okay, so next up, we have show winner. Show winner. Funny thing, I think I use so many functions in this thing that I think it can be very confusing sometimes, but we'll pull through. We're almost there. All right. So show winner. So what this does for us is, okay, let's say I come here now. gonna block me here. I do this now. It's gonna block me here. So basically, what this helps us do is it shows that that the game has been won, and it's gonna help us draw a line. So this is gonna help us draw a line, and in this case, it's the diagonal line. So it's going to basically it's going to check for it's going to see if there's a win, and if there is a win, then it's going to draw the line where the win has been done. So you can see a diagonal line. Let's see if we can do a horizontal line. Let's see if I can trick it to do an horizontal line. Okay, yeah, tricked it. Alright, so you can see, so basically that's what this is there for. That's what this is there for. You can go through it. It's basically just a copy and paste. Not a copy and paste, but it's very similar to what this one is right here. It's just I just copied a few things from here and I put it into here. Then just construct these lines with these conditions, and you have yourself the function. Okay, so now on to the minimax function. Basically this part is going to use the concept of recursion to decide where the algorithm is going to play, and basically on surface level, because this thing it can be very confusing. I'm still trying to wrap my head around recursion. On surface level, what it's going to happen is we have two scores, right? We're going to have infinity and we're going to have minus infinity. And the reason why we have that is the way it works is the algorithm is going to look at it's going to look at as many possibilities as it can, and it's going to try to do the best move. It's always going to go for the best move, and the best move is always going to have like a score. All right. Now, once it has a score, then it's able to make its decision. And one of the ways it's making its decision, it's by either making it either making the score as high as possible or making it as low as possible. So that's why we have infinity and minus infinity. So for this one right here, remember I said our computer or our algorithm is going to be 2. So that's what we're going to set as infinity. So for this one, the algorithm is going to try and increase the score as much as it can. And minus infinity, it's also going to consider what we're going to play. It's not just going to look at what it can play, it's going to consider what we are going to play. And what's going to happen is, let's say we have something like this now. Let's say we have something like this. So we have something like this. Let's say it looks at them. Let's say it plays here. It's going to say, okay, I can play here, I can play here, I can play here. That's the player now. The player can play here, can play here, player. So it's kind of like diverts into it and says, okay, if the player does this, what's the score going to be? What's the score going to be? If the player goes here, what's the score going to be? And then it does this, and let's say it just does this again. So it's now say, okay, if I play here, what can the player play? So it just keeps on going down like that, until it can find the best and optimal route or the optimal decision. So basically that's it. So it's maximizing best score. Probably what I'm going to do is I'm going to put a link to a video that I watched that helped me with the concept of this part here. I'll put that in the link below. So we'll put, or if you want me to really explain this part, then you can just put a comment and then I'll explain this separately because it can get quite long. All right. So basically we have, so like I said, check win, check one, check if the board is full. Now if it's maximizing, then we'll set the best score to be -1000, and for each of these rows and columns, or each of the blocks that are here, we're going to set the, if okay sorry we're going to look at it that if the square is available, then we want to make that square to be 2, and we're going to look at the score. So this right here is the recursion part. This right here is the recursion part. And for here, we're going to make sure we set this back to 0 because we don't want to lose the original state of our board. All right. So the best score is max. Remember I said that this is infinity, so it's going to look at the maximum score between this score that we got here and the best score. So this is just going to keep on updating. It's just going to keep on updating and it's going to be returned. All right. And this right here is just a copy and paste. It's just a copy and paste of this. So remember this one right here is going to be 1000. So this one set at 1000 because we are going to try to update it by reducing the score. This one right here is -infinity. Remember I said that. And basically that's why that's that way. So we have basically the same thing. It's just that we're just going to change this one to be 1, and we make sure, remember, always make sure to include this line, because if we don't do that, our board is just going to get full, like in a few steps. So this is very important. So we're going to minimize the score as much as possible because we are -infinity. We're just going to try and go down as much as we can. Now it's just going to go to, next thing that's going to do is it's going to get the best move, and let's say the score is -1000. Well, I mean, the player doesn't really need this part. This part is really for the algorithm. So I'm going to set this to -1. This is invalid. I can put -2 there if I want, but -1 looks nicer. This part here is invalid because we're still going to update this. Now we're just going to plug this in right here. It's gonna plug this in right here. Remember, this part here is to iterate through our board. So it's going to get the score, and if the score is better than the best score, then it's going to be updated, and then the move is going to be updated to whatever row and column that the loop is in at that point. So basically it's going to make the move where the best score is, and that best score is going to definitely be in one of these boxes. So that's why we have this right here. All right, next step we have move. If the move is not equal to this, I mean, it's most likely not going to be equal to that. So we're going to mark the square. Remember we talked about the mark square function earlier. Yeah, so we're going to mark the square. The player is going to be 2. So we're going to take this guy right here, and we're going to put that into our box. All right, return true. Okay, so this one's just to restart the game. Nothing serious here. For this one, I know I didn't explain it too well. If you would like me to actually explain it in depth, you can just drop a comment and I'll actually go into the details, because I think the video is getting quite long now, so just trying to rush things up. Anyways, we have, first of all, okay, let me quit this first just to show you that I'm not just talking. We have our menu screen, and this one right here is to help us choose what shape we want. So we can choose X, we can choose O. So basic things, it's quite similar to what we've done before. We have rectangle and so if we're dividing the screen by 4 and then do minus 100, that gives us this. And if we do this right here, that gives us this guy. So there's a whole lot of calculation. That's why I said the calculations can be quite tricky. I think it took me quite some time to get the hang of it. Now, okay, I think this 200 to be blue. Yes, it is blue. Okay. Alright, so if I click on this, then you can see if I draw 0, it's not going to be working because it's recognizing that as 0. So no matter how many times I try, it's just going to keep on telling me the same thing. So until I do this, there we go. Now, that's when this is going to work. So, next up, we have our texts. No, very similar to the things we've done before. Once you get the hang of what I've said before, these other parts are quite simple. So we have our text, then we have our position. Same thing with this guy right here. So this is still in the menu part, just to be clear. And then collect points. So okay, so we have our blades. Remember, we need to keep on updating it. If not, the thing's just gonna go away. All right. So once that's done, okay. Remember, we need to put a break because this is a while loop. If we don't, forget to mention this. If we do not put the break there, then we're just gonna be stuck in this loop forever. All right. Now, the next thing is the main game loop. Then we're just gonna fill everything with black again, and then we're gonna have our canvases, and we're gonna fill everything here with white. Let's see what else again. Yeah, I think that's as much as I can explain there. Okay, this. So players 1. So our player is going to be 1 because we could change this to 2, but I mean it is just to make things simpler for us. So game is not over, so that's why the game is false. So having our while loop here, we have our draw lines. Remember I said I put this everywhere because I wasn't quite sure what to do with it again. If I do not, trust me, if I take one of these out, then there's a very high chance it's going to disappear at one point. So I just put it everywhere. So this updates it. So this one I still put in there. I still put in there. So put it in there so that we can quit this anytime we want to. All right. So these help us with. So we are saying that if the mouse button is down and the game is not over, collect the mouse location. And basically this, like I said before, these the floor division right here, these double slashes, they help us to they really help you to round up the numbers to a whole number. It doesn't really aggregate, or doesn't aggregate. I think is that the word, aggregate? Yeah. It doesn't round up, the decimal points or that kind of thing. It just gives you whatever the whole number is. So it's very useful for us to get our position on the board. And okay, so basically the logic here is just trying to say that if whatever position that we've clicked right here is available, I want you to draw the box indicator, flip, that's updated. Now mark the square. Now once this marks the square, then it's going to say that this part is 1. It's going to say that this quadrilateral square here is 1. And it's going to draw the figures. Now it's going to ensure that I actually draw my shape, remember as I said before. And once that's done, I'm just going to click on play and we continue. So all of this is in the draw figures, the draw figures function. Now, check if the players won. If we check if the players won, then the game over will be true. But if not, we can just say that the player is going to be this. So this is modulo 2 plus 1, and basically this helps us change to the next. This helps us change the player to player 2 because we are player 1. The AI is player 2. This helps change the turns basically. Now, if not game over, if best move, draw figures, best move. So this will do the best move, draw figures, and check if they come to a 1. If it has, then game over equals to true. And if it hasn't, then we are going to be the next player. So, okay, let me just add those comments. Change over to the next player. Yeah. All right. So that's right there. So if not game over, then if board is full, game over equals true. Right. So basically, it's just trying to say that this whole thing here is trying to say if the game is not over, whichever player is meant to play is going to play, and once that player has played, check if the game is over. If the game is still not over, then the next player can play, and then we keep on going until we get a winner. Until we get a winner. Basically, that's it. So this part is quite simple. The only part that I might say might cause a bit of headache is this one here. So remember, if you want me to actually explain that, you can put a comment, and I shall explain. Probably do a separate video for that one. Okay, so next up we have key down. Okay, this one's to restart the game. I think we put the. Did I put a function up here? Okay, yeah. All right, restart game. So, see. So our board is going to be, everything is right here. It's going to be equal to 0. So it's going to go back from it's being 1 to. Sorry. It's going to go back from it's being 1 to. Once we play something, it can be 1 2 1 2. But once we press R, I think did I press apart? As I press R, so R means to reset. So you can see pygame.kr. All right. I put R right there. Then this one goes back to this, and then we can start again. So just to show you what that means, do like this. Computer wins. I press R on my keyboard, and we go back. Okay, so everything's back again, and we do everything all over again. So basically, this is just a copy and paste of what's right here. All right. So the game is over. Show the winner, and remember, show winner is. Are we O again? Okay, I didn't recognize that. Let me see. Are we O? Okay, let me try X. Okay. Oh yeah. Sorry, we're X. All right. So X. So we have this, and we have our diagonal right there. So if game over is true, then show winner, and the show winner does this for us. Shows us we've lost the game, which unfortunately for us we can't win. So I think there's nothing we can do about it. So we have that. That's it. Apologies for rushing a lot of these sections right here. I think the video has been going up to 2 hours and something, and I think 18 minutes now. It's quite a long time. So maybe consequently I might just do a separate video for probably the explanation of the CNN part, and one for the Pygame implementation. So, but I'm going to put this on my GitHub account. I'm going to put a link there so that if you want to review the code or just want to inspect it, it'll be far easier. I will put the link below, and hopefully you can hopefully you can see it. But basically, that's it. That's simple game of tic tac toe. To be honest, I've never picked up game development before today, but sorry, I haven't picked up game development before, but this was my first time of using Pygame and interacting with it. So it was quite interesting. It was quite interesting, and it does teach you a lot of things. And I'm actually glad I'm able to implement like CNN in it. So it's been quite nice. It's been quite nice. I think I'll probably try to see if I can go into more of uh, do some more projects that involve game development to just explore that side. Well, here's my first attempt. Here's my first try of making a tic tac toe game. So you can check the link and you can see the code, and hopefully it's helpful to you. So my name's Emmanuel once again, and thank you very much for sticking with me. And I shall see you again in my next project. Adios.